Hello everyone. This is my video number 13 on the topic electric machines. In this video, I will discuss with you why the rotor of three-phase induction motor cannot run at synchronous speed. It always runs at the speed below than the synchronous speed. And hence, the another name of three-phase induction motor is a synchronous machine because it always runs at the speed below the synchronous speed. To understand this topic, I will again draw your attention towards the working of the three-phase induction motor. Here you see this is stator. Inside this we have this rotor. Okay, and I told you that this stator has some field winding over here, while this has some armature winding over here. I'm not drawing all. So for understanding, I am giving one. So this is field winding. This is armature winding. And I told you that the flux generated in field winding is of rotating nature. Rotating means the changing nature because this rotating magnetic field is constant in magnitude, but the direction is continuously changing in the form of rotation, right? So since this flux is of changing nature, it will reach to the rotor through the air gap. And now you see these armature conductors will cut the flux according to Faraday's law, and an EMF will be induced in these conductors. Now, since these armature conductors are having the EMF, due to this EMF, the current will start to flow in it. Since the current is flowing in this armature conductors, now Fleming's law will come in picture, and this you see these conductors will experience a force and will start rotating according to Fleming's law. Now, what happens if the armature conductors, current carrying conductors, will start to rotate at synchronous speed? Okay, once we have understood that armature conductors are rotating, now let us assume that these armature conductors are rotating at the synchronous speed. Synchronous speed is the speed at which this field winding flux is also rotating. You see, the flux produced by this magnetic field state through the field winding is rotating at the speed of synchronous speed, right? Now you are saying, I'm assuming that this armature conductor is also rotating at synchronous speed. Why? Because I'm assuming that this rotor is rotating at synchronous speed. If both field winding magnetic field and this rotor conductors both will rotate at synchronous speed, so you see the concept of relative motion, like you see this is the speed ns, and if I am saying the rotor is also rotating at the speed of ns, now since both are rotating at the same speed, then what will happen? This conductor will not experience any change in flux because you see both are at the same speed. So the flux the which is coming from the magnetic field produced by the stator winding, so it will not be cut by the armature conductors. And since there is no relative change in the flux, so these conductors will not see any change in flux. And if there is no change in flux, then what will happen? No EMF will be produced in the armature conductors. And if there is no no EMF in the armature conductors, there will be no current. And if there is no current, means no current carrying conductors. So Fleming's law will not come in picture, and hence there will be no additional torque, or there will be no torque in this induction motor. And hence we can say, if both this rotor will also rotate at synchronous speed, this mechanism will not be possible. And hence this mechanism will only be possible if the rotor is rotating at a speed which is different from the synchronous speed. Then only there will be a relative motion, and due to relative motion there will be a change in the flux. I hope this concept is clear to you. Let us again see the same concept here. If the speed of the armature winding bounded on the rotor is equal to the synchronous speed, this means the speed of both armature conductors and magnetic field are same. Magnetic field through the stator, coming from the stator field winding. Now, in this case, there will be no relative motion between these two, as the change in flux for the armature conductors is zero. Therefore, no flux will change for the armature conductor, and hence EMF will not induce in the armature winding, right? And finally, the armature winding will not rotate because there is no Faraday law will come in picture first, and then there will be no Fleming's law will come in the picture. Hence, mechanical output at the armature will be zero. Therefore, we can say that three-phase induction motor designed to work at all speed except synchronous speed. Hence, this motor is also called asynchronous. This motor is also called asynchronous. So I hope the concept of rotor speed always unequal to synchronous speed is clear to you. Thank you.